In this video, we are going to look into examples for stability of carbocation. In last video, studied a detail about carbocation, and in last video, we discussed the trend of stability of carbocation. Tertiary is greater than secondary is greater than primary is greater than methyl group, and here we are going to discuss the example. And we are going to account for explanation. Given CH3 thrice C plus, CH3 twice CH plus, CH3 CH2 plus, CH3 plus is the example. According to the trend I given, we can write what is the order, but we don't know explanation. We can write the order. This is tertiary, this is greater than secondary, this is greater than primary, this is greater than methyl. We are writing that order. What is the reason for this stability? Behind this stability, what is the reason? Nothing but that is hyperconjugation. Hyperconjugation is directly proportional to carbocation. So more hyperconjugation, more stable of carbocation, or more stability of carbocation. So hyperconjugation is directly proportional to carbocation. We can explain carbocation on based of the hyperconjugation, and we will also discuss other example which is related to resonance, but mostly important hyperconjugation. And hyperconjugation is directly proportional to alpha hydrogen. What is hyperconjugation? We are going to see clearly. And hyperconjugation is directly proportional to alpha hydrogen. Need to remember how many alpha hydrogen present in the compound, that much hyperconjugating structure will be present in that compound. Now we are taking C plus CH3 thrice. I am writing C plus CH3 thrice, CH plus CH3 twice, CH2, CH3, CH3 plus. And I am elaborating CH3 like this, and CH3 like this. CH3, here no CH3. I am writing this CH3, C, H, H, H. Now you know well, carbocation near carbon is alpha carbon. So here how much alpha carbon is present? 3 alpha carbon. How much alpha hydrogen? 3 plus 3 plus 3, 9 alpha hydrogen. 3 alpha carbon, 9 alpha hydrogen. Here how much? Here alpha position. So how many alpha carbon? 2 alpha carbon and 6 alpha hydrogen. Here 1 alpha carbon, 3 alpha hydrogen. Here no alpha hydrogen present. Hyperconjugation. Hyperconjugation is directly proportional to alpha hydrogen. It take consider only alpha hydrogen. So here 9 alpha hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can draw like this and elaborately, and we also consider how many alpha hydrogen present. So here 9 alpha hydrogen, so 9 hyperconjugating structures. 9 hyperconjugation structures. Here 6 alpha hydrogen, so 6 hyperconjugating structures. Here 3 alpha hydrogen, 3 hyperconjugating structures, 0 alpha hydrogen, 0 hyperconjugation will take place. And how the hyperconjugation? I said about alpha hydrogen is directly proportional to hyperconjugation. Nothing. I am taking simple compound ethyl carbocation. Nothing. This hydrogen will go. This hydrogen bond will alone will go, and hydrogen will look like this. This one possibility resonance. Next, what happen? This bond will go here, and this hydrogen will look like this with no bond. And what is other possibility? This will go there and will become like this. Okay, so this 3 hydrogen will also give the bond, and they will sacrifice their bond and will follow the no bond resonance. So these alpha hydrogen will help by giving their bond, and they will suffer from having bond. So this is only the real resonating structures of hyperconjugation. So that is based on number of alpha hydrogen. How many alpha hydrogens present will be the number of hyperconjugating structure. Here 3 alpha hydrogen, so it will give 3 different hyperconjugating structure. This is the mechanism of hyperconjugation. Each hydrogen is responsible for giving that resonance. So this hydrogen having no bond, here no bond, here no bond. This is the beauty of chemistry, no bond resonance. This like structures are also possible in the chemistry. So one should remember hyperconjugation is directly proportional to carbocation stability. So one should know all structure to find the stability of carbocation. One should determine all structures with the correct stability of carbocation by remembering hyperconjugation, but it's a little complex when the resonance take part, because resonance is the more stable effect than hyperconjugation. If both hyperconjugation structure and resonance structure is present in the stability of carbocation, resonance will be the more stable structure than hyperconjugation. We will discuss these criteria in next example. Okay, I hope this example is more clear for you. Any doubts, just comment in comment section. Thank you.